It's all about the Earth and what we can learn about it from the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Tracy, you have a go right now for that activity.
Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Welcome back. This month on Station Life, we're going to highlight the International Space Station as a platform for observing the Earth and take a behind-the-scenes look at what it's like to live and work on board the International Space Station. They say a picture's worth 1,000 words. It's no surprise that the first pictures taken by humans from space forever changed the way that we view ourselves and our world. Now, if you've ever flown on an airplane and been lucky enough to sit at the window seat, you know that there's a natural desire to look out the window. Well, on orbit, it's no different. On our off-duty time, we astronauts like to nestle ourselves up next to the window and do simply that, gaze at the Earth.
Cutter on the other side of my IDA back here.
Copy, Gary.
Well, easier without the pool stanchion.
Absolutely, yeah. Yeah, it's just like in the pool instead of that, with the exception of that big
Exactly.
As the International Space Station flies 257 statute miles over the coast of Chile, Terry Virts in the initial moments of his first spacewalk.
The Earth is unbelievably beautiful when viewed from the ISS, but as good as cameras are today, they still don't do it justice. Observing the Earth means more than just looking out the window or taking pictures from the International Space Station. With new sensors mounted to the ISS, we can monitor ocean winds, measure clouds, airborne particles, ozone, and more. Think of the ISS as a human-crewed existing platform ready-made for sensors and scanners that can observe all kinds of things that affect us right here on Earth. So one such instrument is ISS RapidScat, which monitors ocean winds for climate research, weather prediction, and hurricane science, which we here on the Gulf Coast really like. So let's take a look at NASA's RapidScat, see what it's all about.
Seeing things like a hurricane develop in its earliest phases, getting a much better idea of its strength than we can from flying one or two planes through it. We can map the entire surface effect of a tropical storm in one pass. The ISS RapidScat is a mission to bring a payload to the International Space Station, and from there we will observe the Earth's oceans and be able to map the speed and direction of winds near the surface.
RapidScat is a scatterometer. It's a radar. It sends out little bits of energy towards Earth's surface that then get reflected back.
If the ocean is flat, most of that energy from the radar just scatters away.
The stronger the wind, the rougher the surface will be, the more energy will be returned to the radar, and then we can convert that energy into a measurement of the wind.
And that'll help us do things like track and predict severe storms, and also learn about the ocean-atmospheric interface.
Especially over the tropical regions, which are of great interest to the United States, because most of the tropical hurricanes that hit the United States come from those regions.
We're launching on a SpaceX Falcon 9 rocket.
The Dragon capsule separates from the Falcon 9 in orbit.
And after orbiting Earth a couple of times, the International Space Station robotic arm reaches out and gently grabs the Dragon as the Dragon, slowly approaches the ISS.
About 2 days later, ground controllers bring the robot arm over.
The robotic arm then reaches into the trunk and grabs the instrument and plugs that onto the International Space Station.
And everything mates robotically. We hook these pieces together and then we get to stay on the outside of the space station for a couple of years. The space station came and asked what relatively inexpensive payloads we could put up on the space station.
We had this hardware sitting there doing nothing, collecting dust for the last 13 years. We might as well try to put it to use.
What if we took some of the existing hardware and tried to fly it in the simplest way possible?
We've put them through extensive testing, electrically tested them, vibration tables, thermal vacuum chambers.
And that leftover hardware meant that we got to save about 80% of the cost in terms of being able to reuse the hardware instead of building new.
And we've added the necessary adjustments needed for this new orbiting platform that we'll be on.
The space station is built out. We know what the external capabilities are. We know we can put science instruments in different places.
We're taking something with a very small team, a very small budget, and a very short schedule, and turning it into something with very real science value.
The global coverage of the Earth is probably right now one of the greatest priorities that people should have in mind when they think about the importance of the space program.
The Earth is a very dynamic, very complex system. And because of the role that winds play, it's a fundamental part of that whole story.
And we need people's awareness and understanding of the importance of NASA's mission to help understand how its climate is changing.
Wow, ISS RapidScat is way cool, and it's definitely going to benefit us here on Earth. Better yet, it's not the only Earth-observing scanner on board the ISS. It has a new neighbor on board. It's called CATS. It's a laser instrument that measures clouds and airborne particles such as pollution, mineral dust, and smoke. In this next segment, we're going to meet the team behind CATS and learn more about how it works.
Hey, John, I'm finished with your model.
Thanks.
So you looking forward to the launch?
You have no idea. My project is a LiDAR instrument called CATS, and it measures clouds and pollution in the Earth's atmosphere. These are important because they affect society in many ways.
So, little Johnny, how does this LiDAR work?
LiDAR is actually quite simple. You shine laser light at the Earth's atmosphere and measure the amount of light scattered back. My instrument will measure...
Today, a team at NASA Goddard is preparing to demonstrate for the first time in space a 3-wavelength laser remote sensing instrument. The Cloud Aerosol Transport System, or CATS, will measure clouds and aerosols in the Earth's atmosphere. To obtain this data, CATS uses a laser that generates 3 wavelengths or colors of light. Internal to the laser, special optical crystals are used to generate these wavelengths by adding the energy of 2 photons to make a single new photon. The final output beam is made up of all 3 wavelengths, and these photons are transmitted in groups towards the atmosphere at the speed of light. As photons encounter clouds or particles, scattering of the laser beam occurs. Very few of the photons scatter directly back to the optical telescope, but the ones that return are collected and counted by sensitive detectors and electronics. By timing the difference between emission and detection, the precise altitude of the particles can be determined. While monitoring global hazards from above, CATS will determine the height, thickness, and extent of smoke, dust particles, and volcanic ash in our atmosphere. Improving cloud data will allow scientists to create more accurate climate models, which in turn will improve air quality forecasts and health risk alerts. This cost-effective technology demonstration will utilize the International Space Station as a scientific platform for up to 3 years. Once proven, the CATS technology can be used to further a larger, free-flyer satellite mission. Until then, CATS will provide information that can help us better understand Earth's complex atmospheric processes.
Well, we have a treat for you. We have with us today a real-life NASA scientist. Welcome to Melissa Higgins to Station Life.
Thank you very much, Tracy. This is fun.
Good. It's great to have you here.
Thank you.
I wonder if you could share with us a little bit about what you do in the Crew Earth Observation Office here at Johnson Space Center.
Sure. What we do, primarily we look at astronaut photography of Earth, so we study Earth over periods of time. We look at imagery from decades ago to just today and hopefully in the future as well. So what we get to do is we look at the crew's ISS orbit tracks on a daily basis, and we'll ask them to take imagery of our different objectives, and those could range from different science experiments, like from principal investigators around the world that we work with, or classroom teachers. We also work with them in specific investigations that the classrooms are doing, and we have the crew take pictures for them, which is very important, I think, because it really introduces the children to kind of the STEM fields of science, technology, engineering, and mathematics, which we think is very exciting. And we also get to do public affairs requests, sort of like we worked with National Geographic earlier last year, and we got to do the Live from Space with them. And we also work currently with IMAX, which they're putting out a new film next year. So we help them with all of their Earth scenes for the film.
That's amazing.
Yeah.
Well, so you mentioned photographs from space, and I know personally from the experience that I had living on board that that is kind of a big project in and of itself. And you listed off a number of things that your office is responsible for. And I just wondered, what's it like? Can you describe a little bit more about what it's like from your point of view, working with the astronauts who are taking photos of the Earth and sending them down?
Yeah, it's great to be able to work with the crew just because we can get that human interaction behind the camera, which we really like to see because it's one thing to have kind of an orbiting satellite taking imagery from space, but it's a whole other thing when you get an astronaut behind the camera taking a picture for us with one of these very large cameras, as
like
you
this.
can see. Of course, it's a little heavier down here on Earth than it is up there. I'm sure Teresa could tell you that.
So much better. That's why we have microgravity. I can tell you that from the perspective of being on orbit and a crew member responsible for taking these photos, first of all, your office prepares a message for the astronauts on board that tells them when to look, where to look, and what settings to use on the camera. And it's up to the astronaut then to be looking at their timeline, which is going about as fast as the space station's traveling over the Earth, 17,500 miles per hour. And what the astronaut does on orbit is they receive this message in the morning of their workday, and they plan their day accordingly because the space station's going over the Earth, and when you're over that particular spot, that's when you've got to have the camera in the window ready to go.
You've got a small window of time.
You've got a small window of time, and you've got a lot of stuff to put together and to hang on to. And it really takes a skill to translate the message that you all send to us, even though it's perfectly written and very clear. The work that we have to do on orbit in order to get ourselves in a window on time, on target, is no small feat. It takes some skill, but also deep respect for the amount of skill and work it takes to not only determine where we want the astronauts to take a picture, but also once that picture comes back, determining where it is, the features, and actually using that photograph for scientific purposes. And that's something that your office is quite good at. I mean, you probably know this Earth better than most people in the world, would you say?
I think I'm getting up there, yeah, I've only got a few years under my belt, but I think, my knowledge of it now is significantly better than before.
Oh, absolutely.
Yes.
That's great.
Associate ISS Program Scientist for Earth Observations, and I'm also the NASA Technical Lead for the Earth Sciences and Remote Sensing Unit here in the Astromaterials Research and Exploration Science Division of the Exploration, Integration, and Science Directorate at NASA Johnson Space Center. So my primary role is to oversee the development and management of the ISS as a remote sensing platform. Well, the ISS is well known for being a crewed platform. It's a crewed spacecraft orbiting the Earth. The past 30-some odd years or so, we've had a number of satellites orbiting the Earth examining the Earth's surface through various remote sensing instruments. The ISS is now becoming a place to put those instruments, similar instruments, on board. In addition to the humans looking out the window, we also have a suite of other instruments that are commanded from the ground, which can be either installed inside the ISS or outside on various external mounting points, including the GEM exposed facility, the Columbus exposed facility, and the external load carrier areas on the truss. And these instruments they're also looking at the Earth for the most part, but they're more sophisticated generally than the handheld digital cameras that the astronauts use. The Science Mission Directorate has now approved a future mission called the JEDI LiDAR, which will fire a laser, an optical system, firing down at the Earth's surface to look at vegetation pattern changes and tie that to changes in climate. We also now have a current laser system on board, the CATS, the Cloud Aerosol Transport System, and that's firing a laser into the upper atmosphere, looking primarily at particulate distributions and seeing how that affects differences in atmospheric chemistry and atmospheric patterns. Well, there's two things that we can gain from putting these instruments on the ISS. One is the ISS is in a fundamentally different orbit around the Earth than a lot of the robotic remote sensing instruments that we currently have. They're in polar orbits, which means they're oriented at 90 degrees to the poles, and they collect data on a roughly 12 to 14 day recurrence. You have the capacity from the ISS to collect really a fundamentally different kind of data than you collect from the other orbiting satellites. So it's a very complementary data set. The second item is that the ISS is sort of a cheap tryout platform for sensors. People who are developing new instruments or people who have built instruments that were planned to fly on other satellites, but then for one reason or another, the mission got scrubbed, funding got cut, what have you. They still have the sensors built, and if they have a complete sensor that's sitting on a shelf somewhere, the ISS provides them a new platform to put this sensor on. And typically, if NASA will fly the sensor up, particularly if it's already built. And so it's a nice sort of a cheap scenario for people to get their sensors up there, collect the data they need without having to wait for a new satellite platform to be designed or to design that platform themselves. I'm Will Stefanov. I work for the ISS Program Science Office here at NASA Johnson Space Center.
As you can see, our International Space Station is an unprecedented research platform in space, allowing researchers and scientists to conduct experiments that can't be done anywhere else. So 2 more experiments, we call them payloads in our world, are scheduled to get on board the ISS in 2016. Get ready. There's SAGE 3 and Lightning Imaging Sensor. SAGE 3 will measure ozone and other gases in the upper atmosphere and help scientists to assess how the ozone layer is recovering. And LIS will monitor global lightning for Earth science studies and support operational weather forecasting and warning. Looks like utilizing the ISS to further benefit all humankind is right on track. Thanks for joining us on Station Life at our behind-the-scenes look at using the International Space Station as a platform for studying the Earth. Be sure to follow us on Facebook and Twitter for the latest research news. And don't forget to download our new app on your mobile device. Until next time, we're working off the Earth for the Earth.